All right, so in the companions, I'd like to see you guys on, I think it's 3. Yeah, page 3. Okay. So we're covering day 2 of section 1-1. So let's start with the protractor postulate. I think what I'm going to do is I'm going to try to increase this real quick because we might need this picture. No. Come on. Oh, come on now. Okay. Whew. Might need to. This picture to just be a little bigger, but we'll see. So this is a protractor, okay? What happens here is that if we line up this device, it always measures angles. So if you look right here, you always start, there's like a little eyelet or a cross or something on a protractor, and you always line it up with the middle of the angles where everything meets, okay? From there, you line up with the 0 degrees or the 180, okay? So the line there, so that this way you can get an accurate measure, okay? Now, when you're looking to the left of a protractor, you're looking using the outside numbers. So if I wanted the angle A, B, C, I would just look at the outside numbers, and I know that this is 60 degrees. If I wanted D, B, C, I would look at the inside numbers because that's where 0 starts, and I follow those, I would see that this would be 120 degrees. Some protractors don't have like individual tick marks, some do. Some also don't have both numbers. So what you would do here is if you knew that was 60, you would just subtract to get this one. Okay. So taking a look at example 4, it says, what is the measure of BEC? Well, one thing I'm going to do is I'm going to increase the lettering here a little bit. And see if I can just make this a little bigger for you guys. Sorry, I have to like edit slides like while I'm teaching, but last hour it was a legit mess. Okay. So all I'm doing is I'm just going to increase the size of this so you guys have it. Okay, so why did it? Okay, I'm not enjoying this. Give me 1 second. Fine, here we go. That'll help. All right. So now I can just move this around. There we go. Okay, so if we take a look, all right, they want the measure of BEC. So if we look right here, here's B, here's E, here's C. One thing we know is that if I measured AEB, that is going to be, I guess they're saying it's 47 degrees. I don't like to approximate that stuff. Usually there's little tick marks there, but for some reason they didn't include them in this. So they're saying that's 47 degrees, and then they're saying the measure of AED, or you can even do the entire measure here of, let's see, AED is 130 total. So from here to here is 130 degrees. And now if you want, you can subtract those. There's a lot of things you can do. You could also look here. It looks like this is at, 105 from here to here. So kind of mark it up and see what you can use to solve. And it looks like if they want BEC, I'm just going to kind of highlight that real quick. If they want this one, that means we can get by without even using this angle at all. Okay, so that would mean I am going to take, looks like I'm going to have 105 minus 47 to get this angle right here. I'm going to take the absolute value because, again, it's a measure, has to be positive, okay? So that means the measure of angle BEC is going to equal 58 degrees, okay? So that's how that works. Now, they're going to want you to use this picture. Can everybody see it? For the triads. Why don't you guys give the triads a shot? But I want you to change something around. I'm going to see if I can just copy this and put it on the next slide. I don't want you to find BED. I want you to find CED. So just replace that B with a C. I don't want us to have to reinvent the wheel with this. Okay, and I definitely don't want you estimating. So I want you to find those two angles using this protractor. Go ahead. So what do we get for letter A? Who's got letter A, which is the measure of angle AEC? So we're going A to E to C. Go ahead. 105, perfect. It lands right on that 105 mark. Excellent. What about CED? Who's got that one? Go ahead. 25. Nice job. So if you look, you're going C to E to D, and you know the whole thing is 130. That's one thing you can do. So you can state 130 minus the 105, and that should give you 25. Okay? Questions on that? Yeah. Yeah, I told you to replace it with the B with a C. Yeah, because BED is kind of, it wasn't that great. Okay, any other questions? All right. Let's move on. Okay. So we've already copied this down. This is the angle addition postulate. So we should be good there. Remember, you're gonna need that for your note, right? For your proofwriting coming up here. So let's take a look at this example. It says use the angle addition postulate to solve problems. A lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees to the left or right from the shown standing point. The beam of light from the spotlight forms a 22-degree angle. Can the designer use the spotlight to light each of the objects on stage? All right, so what they're saying is if you can, it can only rotate 25 degrees left or right, which means everything has to land less than 25 degrees. Okay? It's not like we can add to it. This thing is on a pivot. It's not going to go any further. All right? So what they're saying here is draw and label a diagram to represent the beam angle, the angles given, and the unknown angles. So in this case, this is the picture you're going to want to copy down, okay, for this example. We're going to do this again, so I'll leave that one up to you. But one thing I always like to do is I like to highlight what I got, all right? So if I want to solve for x first, I'm going to attempt to anyway. I'm going to highlight this angle going to this angle. Now, why am I highlighting this? Because I have what this angle is totaled to, okay? And I have the smaller part. This is the part I don't know, but I have this entire large angle. And this is the ray that is breaking up that angle, okay? So what this means is I'm going to take this and I'm going to state if I had x plus, and this little guy right here is 22 degrees, that whole thing has to equal 57. in order to find what x is equal to, that x angle. Subtract the 22 from each side. This leaves me with x is equal to, looks like 35, okay? So that's where the 35 is coming from. Questions on how that works? Excuse me. All right, so now for the next one, we have to solve for y. I gotta turn those off. There we go. Okay, so now to solve for y, what we're going to do is, again, we're looking at what we have in total. All right, so in this case, I'm going to use the entire angle. I know I have this guy right here, and this is the ray in question. Okay, so I have the 74 total angle. I have this whole thing is 57, and this is the part I don't know. So I'm going to put this as y plus 57 equals 74 degrees. I subtract the 57 from each side. This is y is equal to, in this case, 17. Now, in order for this spotlight to hit, it needs, these degree measures need to be less than, okay? Need to be less than 25, because the 25 is kind of the max rotation, right? So what's not going to be lit here? The chair, the door, the rug, or the table? The chair won't be lit, yeah, because it can't go that far. If this has to be less, oh, I'm using the mouse. This has to be less than 25 degrees. This will light, that won't be a problem. Questions so far? Ready for the next one? We're going to do this again, but with a different number. Okay. All right, so looking at the you try it. Okay, I included the picture, all right, but something's going to get replaced. So it says, refer to the example 5. Can the light designer use a spotlight with a 33-degree beam angle that can rotate 25 degrees to the left and right of all objects on stage? So what happened here is that this 22, I don't know why it's doing this to me. Sorry, this is acting weird again. This 22 is becoming a 33. So same picture though. Don't be afraid to draw things out and muck them up, right? Especially using colors, it'll help out so much. All right, so to solve for x, I know that I have this entire angle with this as my ray that breaks it up. I also know I have this 57, and I don't know what this guy is. So this is going to be x plus 33 equals 57. Someone tell me, what does x equal here? Go ahead. 24. What'd you say? 24. Very good. Sorry, just couldn't hear you. Everybody with me there? So far, is this going to light up? Is it less than 25 degrees? Yep, so we're good. That's going to light up. Let's take a look at the next one. So again, we're taking the entire angle in this case. And this is the ray that's busting it up. I know that I have this whole angle, and I have what I'm trying to solve for, but the entire thing is 74 degrees. So this is going to be y plus 57 equals 74. And someone tell me, what does y equal here? Good? 17. Is this less than 25? Yep. So is the whole stage lit? Yes, it is. Does that make sense? A little bit better with the second time around, I hope. Okay. All right, let's take a look. Now, example 6, for some reason, Savas did not originally include it, so I'm going to go over that now. Is anybody still writing this down, though, before I move on? Okay. So everything's kind of on one slide, guys. So example 6 says use congruent angles and congruent segments. So we need to start identifying what is congruent and what is not congruent, okay? So it says if the measure of angle XWZ is 127 degrees, what is the measure of YWV? All right, so I'm going to write some things down. The first thing they're telling me is that XWZ, so the whole thing is 127 degrees. Oh my goodness. Let me make that look a little bit more legible, huh? Okay. But the other thing they're giving me is this right here, is that this is 32. And there's this little arc right here and a little arc right here. These arcs mean that they are congruent. So if this is 32, what does this guy have to be? Yeah, 32. Do you see what I mean about like mucking up the picture? Put the useful information in to help you out. All right, so now they're telling us, hey, what is, let's see, it looks like they want, what was it? YWV. So here's Y, here's W, here's V. I'm going to label that with an X. So when I set this up, I'm going to set it up as the measure of angle XWZ, so the entire thing, is equal to the measure of angle XWY plus the measure of angle YWV. Sorry, it's a little curve there, but then also plus the measure of angle VWZ. So the angle addition postulate, it works for more than one angle as long as it all combines. Okay. So that means I have 127 equals 32 plus X plus 32, if I just put that in order. Okay. I'm going to have 127 equals 64 plus X, and then I subtract the 64 from each side. So that leaves me with X is equal to 63. So that means the measure of angle YWV is in fact 63 degrees. Does that make sense? Anybody writing this down or anything? I just want to make sure before I'm going to erase it to make room for B. Okay. All right, letter B, it says, what is HF? So one thing I always like doing with segments is I like highlighting what they want me to do, okay? So I'm just going to highlight that real quick. Now, the next thing they're saying, okay, so if I have all of this, the next thing I'm going to do is I'm going to label what's congruent with what. So we have a single tick mark here and here, which means those two sides are congruent. And we also have one here. So that means this is 8 and this is 8. Do you guys see that? Now the double tick marks are congruent to each other as well. So here we have 11. That has a double tick mark. This has a double tick mark. This is 11 as well. So if I want to find HF, that's the same as saying HG plus GF. So I am getting HF is equal to 11 plus 8, which gives me 19. Oh, 19 centimeters. It does have a unit. Does that make sense where that's coming from? So you have to identify this stuff in your homework tonight. What's congruent, what's not congruent, and solve using those congruency statements, okay? Why don't you guys try it, example 6, a shot A and B. Now the picture is right here for you if you want to copy it down. I don't know if I can't really make it any bigger because I had to copy the whole thing real quick. But the measurements should be the same. So you should have some of it, but I would write it down and then muck it up. Okay. Give it a shot. Decimals. Yeah, don't fear the decimals or the fractions, guys. You're gonna see a whole lot, okay? Oh, you're fine. Figure it out.
Yeah.
Okay. Show of hands. Who's done with A? Who's done with B? All right, we're good. I'll give you more time. Not a problem. How are we doing? And we give it one more minute, and then we're gonna go over these two, okay? All right. I'm going to talk about B first, only because I think that was the one that was like the trickiest. So they want you to still use, it says in the figure in part B above. So I want you to look at this again. Suppose D equals 11.5. So I'm going to add that in. So CD is 11.5. DE is 5.3. So this guy right here is 5.3. And the perimeter of the figure is 73.8. So perimeter, what's perimeter? Who remembers what perimeter is? Yeah. Yeah, you're going to add it all up, right? Just everything. It's like if I put a fence around this room, I would just add together all the walls, right? So in this case, what I'm going to do is I'm looking, I'm like, okay, I have this, the whole thing they want us to find, it looks like GE. So this guy right here, which means we're going to find this part first. So this is going to be 73.8 equals 11.5 plus 5.3 plus 8 plus another 8 plus 11 plus another 11. This is my x plus 8. Does everybody see where that's coming from? Started here. There's and I'm going to double check because there's a lot of links here, right? 11.5, 5.3, there's 8, there's 8, there's 11, there's 11, there's my x that I'm trying to find, and there's my additional 8. Someone tell me, what does x equal when you get this all figured out? Calculators are helpful. Yeah. You got 5.5? Yeah. I got 11. I did get 11. So what I got was 62.8. I had like x plus, oh, sorry. I don't know. That doesn't help, right? I ended up getting like 70. Oh my God, come on now. 73.8 equals, 62.8 plus x. Does that look right? Yeah. And then you subtracted the 62.8. So that means if this is 11, what else is 11? Good. GE. So GE is equal to 11 centimeters. Does that make sense now? A little bit? You are going to have to do things like that in your homework. There's one with angles where it's like they're going to give you like different measures, and you're going to have to see what's congruent in order to subtract to get the angle that you need. Okay? That is in your homework tonight. Let's take a look at 6A. If the measure of NOP is equal to 31 and the measure of NOQ is equal to 114, what is the measure of ROQ? I think this one, I walked around the room, most everyone got this one. Who can tell me what the answer is for letter A? 41.5. Nice job. Does anybody need to see this one? Yeah? Oh, okay. All it takes is one person, just FYI. All right. So yeah, that one was 41.5. Questions? You guys are out of here when? When is it? 8, what? 06? Okay, you got 6 months. All right, well, we'll call it there for today. Go on, but I do want you guys to at least get your computers up. Go on Savus and make sure everybody's getting in. I got a few emails. I just want to make sure those are figured out. Okay. Those of you watching at home, have a great day.